All right, this is 4.1, Chapter 4, Lesson 1. Excuse me. What should have happened already is I've showed you how to do a reflection with your geometer. So remember, there's the black line of your geometer, and we're always using the centimeter side. So here on this practice worksheet, they asked us to reflect the following triangle over line M and label these points. They haven't asked us to reflect a triangle yet. We've just reflected points, but that's all we're going to do anyway. Is since this triangle has vertices A, B, and C, we're just going to reflect those points one at a time. If we reflect A, then reflect B, and reflect C over those lines, then we can just connect those dots together and create that triangle right there. So first thing we do in any reflection is extend the line out very much longer. So go ahead and take your straight edge, extend that line out very much longer, and then what we're going to do is take our geometer and place the black line of that geometer on top of this line that we extended out very much longer. Now I don't have a geometer on this InterWrite board, but I do have this ruler, so I'll do my very best. But remember, just place your black line, which is the red line in my situation, on top of the line you extended out very much longer. And this edge right here is the centimeters edge of your geometer. Go ahead and line that up with the point you want to reflect. Let's say we're reflecting A. Okay. Now, all you have to do now is count how many little tick marks A is away from line M. Now, obviously, your paper and my problem are going to be different. I have a different ruler, and I blew this picture up a lot bigger. So all you have to do is count how far away is A. So it's 5, 10, 15, 16, 17, 18, 19 away on my picture. So I'll go 19 away over here, 5, 10, 15, 19. Place a dot there, and go ahead and call it A prime right away. And then we could do that again for B and for C. So I've already got that prepared. Why don't you go ahead and reflect B over line M by lining that up and just count how far away, and then line C up, and it should look like that when you're all said and done. And then all we've got to do to create the triangle is take our straight edge. Let me get this ruler out of the way here. Take our straight edge and connect the dots together. So bingo. Go boom, boom, and boom. And there we just reflected triangle ABC over line M and got triangle A prime, B prime, C prime back. So that's what it'll look like. Next problem, they want us to reflect the following angle over line N. So again, first thing you do is extend line N out very much longer. The reason why you do that is it keeps your geometer perpendicular with the line you're reflecting over. So we'll do that and reflect A, B, C, D, and F. Go ahead and do them all. So go ahead and pause the video. I've got that done already. Just pause the video and get those 5 points reflected. And then once you've done that, all you have to do is take your straight edge and connect those puppies together. So a lot of pausing until you get this done. And then that brings us to our next part of this question right here, which is the reflection postulate. It says the reflection postulate is sometimes called the ABCD postulate. The reason why it's called the ABCD postulate is because there are 4 things that are preserved by every reflection. They start with the letters A, B, C, and D, so each one of those things starts with this letter. And here's what A stands for. A stands for angle measure. Angle measure. So, measure. I can't spell. Angle measure. What that means is if this original angle right here measured 30 degrees, then if I reflect that angle over here and get this green angle, the green angle should also measure 30 degrees. It's not going to grow or shrink or anything like that. Reflections preserve angle measure. Keeps the measure of that angle exactly the same. B stands for betweenness. Betweenness is preserved by every reflection, meaning in this original picture, point B was between A and C because they're collinear and B is between there. So that means when you reflect them, B prime should be between A prime and C prime. They're not going to jump out of order or anything like that. C stands for collinearity. It's the word collinear with I-T-Y at the end. Collinearity. C stands for collinearity. A, B, and C were collinear points, so A prime, B prime, C prime. If you do a reflection, points won't jump off line or anything like that. And D stands for distance, is preserved. So these 4 things are are preserved by every reflection. That means if this distance from A to C was 2 inches, then the distance from A prime to C prime will also be 2 inches. It's not going to grow or shrink or anything like that. So reflections preserve angle measure, betweenness, collinearity, and distance. And we'll use a couple of these for justifications as we go along today. So let's keep on rocking. In the picture at the right, what is the orientation of triangle XYZ? Orientation, in our own words, means what way around the clock are the letters going. Like when they call it triangle XYZ, okay, that means start with X since it's the first letter, and just go around the clock XYZ in the order that they tell them. XYZ, from X to Y to Z, going around the clock. Is that clockwise or counterclockwise? Well, that's counterclockwise. Good deal. What would be the orientation of its reflection image? Remember, the beginning guy is the pre-image. You haven't done anything. And if I reflect that puppy over there, well, X would reflect over here. I'm just going to do a rough sketcher to X prime. Y would reflect over here somewhere to Y prime. And Z would reflect right here to Z prime. And I connect them together. And you have to go in the same order. If this went X, Y, Z, you have to go X prime, Y prime, Z prime. So if you go around the clock that way, X prime, Y prime, Z prime, that went clockwise. And what that means is reflections reverse orientation. Reflections reverse, if I could speak today, orientation. Meaning if the original guy's counterclockwise, then its pre-image was clockwise. We can go back and see right here in that first problem that we did with the triangle, if I called it triangle, come on, keep going backwards. If I call this triangle ABC, then triangle ABC, going around in that order, counterclockwise. To go A prime, B prime, C prime, you would go clockwise. So reflections do not preserve orientation. They preserve these four things: angle measure, betweenness, collinearity, and distance. But one thing not preserved is orientation. Number 4, they want me to draw this. The question I have for you is, can you say this out loud? The little r stands for reflection. So they're asking you to draw the reflection of, and then you say the name of this dude, like it's just called ABCDE. Draw the reflection of ABCDE over this line's name, line AB. Draw the reflection of ABCDE over line AB. So we just go one point at a time, A, B, C, D, and E, and we reflect them over this line. Start by, of course, extending that line out very much longer. And first I want to reflect A over that line. Well, since A is on that line, right, it's line AB, you know it's on there, it's not going to move. If you measure how far away it is, it's 0 centimeters away, so you would not move it at all. And B is on that line, so it's not going to move at all. So honestly, all you have to do is reflect C, D, and E, and make sure you label them as you go. When you reflect C over here, don't just put a dot here, then reflect D and put a dot there, and then put E here, and not put their names, because you're going to get very confused when the pictures get more complicated. Once you reflect C, call it C prime right away. Once you reflect D, call it D prime right away. So when you do that, I went ahead and measured things out perfectly, and it'll look like so. Go ahead and pause the video and get that done if you need to. Then you need to connect those dots together, and it gets a little tricky on how to connect things together when there's more than 3 points. So they just go in, like, look at your pre-image here. Since A connected to E, that means A will connect to E prime. And E connects to D, so E prime should connect to D prime. And something screwed up there. So E connects to D prime. D connects to C, so D prime to C prime. And B connects to C, so B prime to C prime. So there, I have reflected A, B, C, D, E over line AB. Number 5, we get a little bit of a problem because everything we've reflected so far has been straight. You know, it's had straight edges. This has got a curve for an edge right here. So what we can do first is all of these cornery type points right here where there's a definite corner, why don't we go ahead and label those just A, B, and C, and extend out line M, and go ahead and pause the video and reflect A, B, and C over that line right away. So go ahead and do that. It'll look like so. And then I connect them together as well. And what you want to do next is, you see on this bad boy right here where this curve kind of starts to max out. Like I'm going out, 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 out. Then all of a sudden I start coming back in. So where the curve starts to max out, that's like its vertex type point. I'm going to put a point D right there. And I'm going to take that point D and I'm going to reflect it over that line. So I found the max out point and placed it on there and reflected it over that line. Actually, I called it C on accident. I should have called it D. So D, my bad. And then what you want to do is once you get over there, then we're just going to do our best freehand ability to kind of connect this together. It's just going to be a rough sketch. So as best you can, I know we're not all artists here, but do some sort of job to connect that back together. And yours might look worse than mine. Hopefully yours looks better than mine because that looks pretty bad. But just do your best freehand job. If you want to get more accurate, you can place more and more points on this original pre-image right here and like connect those together. But that's what we're going to do to deal with the curve stuff. All right. Moving on, number 6 says, draw and label a figure that shows the reflection of RQTS over line C is RWTY. So they want us to start with our own figure. I have a line drawn already. That's where we got to start. You know, it's like the name of the line is C. I did that right here. So we got to start with a line, and you might as well make it a long line since our first step is always to extend that line out very much longer. And people try to make this problem more complicated than it actually is. All they have to do is go one point at a time. According to this reflection statement right here, this point should reflect to that point. So R should reflect to R. Well, there's only one way that R reflects to R. Since it reflects to the same letter, that means R has to be on that line. So I have drawn R on the line somewhere. It doesn't matter where, you know, but just put R on that line somewhere. So I've done that point. Next thing is Q should reflect to W. So what that means is, since those are different letters, that Q has got to be off of the line somewhere. So what do you say we put Q somewhere like right here? Doesn't really matter, but we'll go ahead and put Q right there, and now reflect Q over line C. And when you do that, don't call it Q prime. They want you to call it W. So put a point Q somewhere off the line. It's got to be off the line, and reflect it and call that point W. So I got Q in red, and I got W in blue. Then the next point is T. It reflects to T. So since it reflects to itself, that means it's got to be on the line. So put T on the line somewhere. Doesn't matter where. And then S is the last point. It reflects to Y. That's where you got to be a little bit careful. Okay, you can't just put S anywhere you want to. Like, let's say I decided to put S right here. What you have to end up doing with these, this is a bad place for S, and I'll show you why. What you have to end up doing is this should be some sort of quadrilateral, right? 4 letters in a row means that's a quadrilateral. And if I connect them together, they have to connect in this order, R to Q to T to S. So if you go R to Q to T to S, and then the last letter S has to connect back to R again, when I draw that shape, that's not a polygon, right? Because this segment intersects in more than exactly 2 places, 1, 2, 3. So you got to be careful of where you put S. So what do you say you follow my lead right here, and let's put S like right here somewhere. So I'll put S there, and it reflected to Y. I've drawn that. Now connect those together. So I'm going to connect all my red segments first. This first dude, I'll highlight it red right here. This is the red guy, RQTS. So R to Q, Q to T, T to S, and the last letter goes back to the first letter. I reflected that. Then you got to do your blue dude. So switching colors. Same order. R goes to W, W goes to T, T goes to Y, and Y goes back to R. Are you going to the mall today, Billy? And there we go. I have drawn a figure that shows the reflection of RQTS over line C is RWTY to the back side. Use this figure at the right where the reflection of triangle RMG over line GN is triangle BPG. And then they give you some situations here. They say if the measure of angle P is 46 degrees, here's angle P right here, 46 degrees. Find the measure of angle M. Well, angle M is right here. And you notice, what's the reflecting line? This bad boy. I'm going to highlight it. Here's the reflecting line in blue. So we've got the reflecting line in blue there. Does P reflect to M? Does angle P reflect to angle M? Well, you can tell up here by this reflection statement, P comes second. What comes second over here is M. So since P does reflect to M, that means angle P should reflect to angle M. And if angle P's measure was 46 degrees, then the measure of angle M should equal 46 degrees also. And my question is why? Why should these angles be the same? Here's our justification that I do want you to write down. Remember the ABCDs, angle measure between its collinearity and distance? We're going to write this down. Reflections preserve angle measure. Preserve. Reflections preserve angle measure. That's how we know. We're going to do some justifications. You'll see them on a quiz and test. Please justify how you knew that. Reflections preserve angle measure. In part B, we got to be careful and read for detail. Let me get rid of all this information here real quick. Measure of angle BGN, I'm going to highlight that, and I'm going to go light green, BGN, from B to G to N. Right, that's that green angle right there. It's 70 degrees. They're asking you what's the measure of angle RGB. I'm going to highlight that in red, RGB. Well, the green angle definitely does not reflect to the red angle. This is the reflecting line again, right here. Okay, but what's true is, wouldn't the green angle reflect to this blue angle right here? So the blue angle should measure 70 degrees because reflections preserve angle measure, and then the red angle would measure 140 degrees because of why. Where did I get 140? Oh, that's the angle addition property, right? So it's kind of a two-stepper. We had to do reflections preserve angle measure, then the angle addition property. We don't have to write anything down. They didn't really ask us to. Here it says this, what's that say again? Oh, the distance from R to G equals 2. Put it in the picture. Then find the distance from G to B. That's got to be 2 as well. Why? How do you say this out loud again? What's the first thing? Oh, distance, reflections, preserve, distance. That's what I want us to write on that one. That's the justification. Reflections preserve distance. Angle measure between this collinearity and distance. These two dudes right here that I have circled will be justifications that we'll write down. Reflections preserve angle measure, reflections preserve distance. We'll never really see reflections preserve betweenness and reflections preserve collinearity as justifications for like why something isn't a problem. But these two we'll do often. Now we're going to actually say, what if we wanted to reflect something on a graph? We're going to reflect over 4 lines. Either the x-axis, remember that's a line, that's this dude right here on the graph. The y-axis, which is in blue here. The line y equals x. Is this in slope-intercept form? You bet, because y is all by itself. What's the slope? 1. What's the y-intercept? 0. So that would be this green line. Let me highlight that in green. Y equals x. Y-intercept is 0. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. That's this line right here in green. And the line y equals negative x. What color am I missing? How about purple? Y equals negative x is in slope-intercept form. It's got a slope of negative 1 with the y-intercept of 0. So that will actually be that purple line right there. Those 4 lines are what we're going to reflect on. And here's the rules that we have. What we're going to do is, on your paper, we're going to translate this rule into actual English right here. So let me make my eraser a little bit bigger here. Okay. To reflect over the x-axis, here's what this says. If I had some point AB, the AB, where this is the x value, that's the y value, right? If I had just any point in the world, to reflect that point over the x-axis, What changed from the original guy to the second guy? Did the x value change at all? This is A, that's A, so it doesn't change. Does the y value change? Yes, this was positive, that's negative. Well, what that really does is it changes the sign. So to reflect over the x-axis, the rule is you change y's sign. Change y's sign. Like the point 3, 1 reflected over the x-axis would be 3, negative 1. X value stayed the same, change y's sign. To reflect over the y-axis, the point AB became negative AB. The y value stayed the same this time, and the x value changed, so we're going to change x's sign to reflect over the y-axis. I hope you're writing these rules down on this piece of paper. To reflect over the line y equals x, do you notice that no signs changed because these are all positive, these are all positive. There's no negative symbols. No signs changed, but the A and the B switch places, so you're going to switch x and y around. So like the point 4, 3, if you want to reflect it over the line y equals x, will become 3, 4. And we'll see examples of this here as we get going. We're just writing the rules down. And there's probably a typo on your sheet unless I had changed the copies already, but if this says negative b, a, we need to just cross that out. The rule has to be the point AB goes to negative b, negative a. So what you want to do first is switch x and y, then change signs. Change both signs. Switch x and y, then change both signs. So here's 6 problems. They're actually pretty basic, and they should be very, very easy to do when you have the rules right here in front of you. Reflect the point 4, 3 over the y-axis. So here's the y-axis. The rule says change x's sign, so that would become negative 4, 3, and so on. So let's go ahead and do all these. Reflect over y equals x. Rule is just switch them around, so negative 1, 2. Switch x and y around. Reflect over the x-axis, that's change y sign, so negative 3, 9. Reflect over the line y equals negative x. Switch places and switch both signs, so negative 6, negative 6. Reflect over the y-axis is change x's sign. Well, x is 0. There's no such thing as negative 0. 0 is neither positive nor negative, so it's still going to be 0, 3. Hey, this point reflected to itself over the y-axis. What does that mean about that point? Like back here, when we had t reflect to t, didn't that mean t was on that line? If 0, negative 3 reflects to 0, negative 3, doesn't that mean 0, negative 3 is on this line? So that point right there is actually on the y-axis, 0, negative 3. And the last one, reflection over line y equals x, we're going to switch them around and go 2, negative 2. So that's real easy if these rules are in front of you. The problem is, on the test, those rules aren't going to be in front of you. So we got to memorize them. Let's do this now. They want us to actually graph this triangle first and reflect it over this line. So the first thing I want us to do is whatever line that they are asking us to reflect over, let's graph it. Let's actually, with a straight edge, graph this line, y equals negative x. It's got a slope of negative 1 and a y-intercept of 0, so start at 0 and go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Put 4 points, take your straight edge, and connect the dots. Don't forget arrows because it is a line. So start meow, and then get my grabber. Let's make that bad boy go through the grid also. So first thing we do, graph the line. Second thing you do, plot the points of the pre-image. The pre-image is this dude, A, B, C. So A is at 3, 1, 1, 2, 3, 1. Go ahead and put an A there. B is at 4, 3, 4, 1, 2, 3, 4, 1, 2, 3. And that's a B. And C is at negative 5, 1, 2, 3, 4, 5. Negative 2. So there's C. Take your nice C. Take your straight edge and connect those together. A, B, C. All right. There you go. Now they want us to figure out where A prime, B prime, and C prime is. So we got to know the rule for reflecting over the line y equals negative x. That means make them switch places and switch signs. So I'm going to go blue here. A prime would actually be at -1, -3, switching places and switching signs. B prime would be at -3, -4, and C prime would be at 2, 5. So I'm going to plot those points. -1, -3, that's A prime. B prime, -3, 1, 2, 3, 1, 2, 3, 4. And C prime, 1, 2, 1, 2, 3, 4, 5. And connect those together. Oops, color. It's not pretty unless you match the colors up. And hot tamales right there. So what you could do, let's see if I could actually do this, is now you could take your piece of paper. Well, that's not going to work. I was going to say you could take your piece of paper and turn it to where this line is running vertically now, but I can't do that because my picture won't change. But you can see that these two do reflect to each other over that line. This reflects right over there, and etc. So uno más, my friends. Reflect over the y-axis. My bad, I can't read. The x-axis. The x-axis is right here. You can graph that line if you want to, but it's already done for us. You just need to plot those points. A is at -2, 1. B is at 3, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. And C is at 1, -4. 1, 2, 3, 4. Right? Okay. Connect them together right away. You definitely don't want to try to connect them together later. It's just difficult that way. Connect them together right away. We're going to reflect this over the x-axis. So that means switch y sign. So -2, -1. 3, -6, and 1, 4. Don't forget parentheses around all those points. So -2, -1, A prime. B is at 3, -6, 1, 2, 3, 4, 5, 6. And C is at 1, 4, 1, 2, 3, 4. C prime, and connect them together, and that will do us. Cool. So that's our video. Please come see me if you have any questions. Have a good one.